So, as I was saying earlier, scalars and vectors is one of the important aspects that you must be familiar with as far as physics is concerned. So, I hope we can see the screen, right? Can we see the screen?
Yes, sir.
Yes, sir. Okay, okay. So, now first thing there, that's the scalars. So you need to know what scalars are. Talking about physical quantities in physics, what we deal with in physics is basically physical quantities. Now, physical quantities may be fundamental and may be derived. I hope you all still remember your seven fundamental quantities, right? Do we still recall those seven?
Yes, sir.
Okay. And as well, you have your derived quantities as well. Now,
Yes,
those
sir.
those divisions are based on dependency and independency of quantity. However, physical quantities may also be divided into two based on magnitude and direction, or based on direction. So the first one will be scalar and the second will be vector. So what you need to know about the scalar is that it's a quantity that has magnitude only and has no direction in space. So you expect it not to have direction. But of course, it has magnitude. So magnitude means only just a numeric value. So examples of scalar quantities, you have the the weighing balance. Sorry, you have mass. Like when you put a mass here, you are able to measure the value only. It's not going to give you a specific direction. So mass is one of the is one of the scalar quantities that you need to know. Volume as well. This is used in measuring volume. Volume as well is also a scalar quantity, and also time as well is also a scalar quantity. As a matter of fact, all of the fundamental quantities that you have, mass, length, time, luminous intensity, electric current, which other one there, amount of substance. So those quantities there are all scalar quantities, okay? So you need to know that. So you can see length is also a scalar quantity, area is also a scalar quantity, volume is also a scalar quantity, time as well, and also mass. Are we clear?
Yes, sir.
Oh, very good. So now next one is vectors. So what are vectors? Vectors are quantities that has both magnitude and the direction in space. So it is very important for you to know this has the direction. So examples of vector quantities. So vector quantities are able to tell you, okay, this is the specific direction the person is going. For example, maybe someone moves 20 kilometers due north. That due north tells that, okay, that is the direction the person is going to. Okay. However, if you just say a distance of 20 meters, that 20 meters is only a magnitude. It's not, it doesn't have a direction. So because it doesn't have a direction, we call it a scalar quantity. So when you are trying to exert a certain amount of force on this object. So force is said to be a vector quantity. Why? It has a magnitude, of course. We are using a certain numeric value to push this thing forward. And the direction that it tends to go, which is the direction of the force, is the direction. So it tends to be a vector quantity, okay? So displacement is a vector quantity. Displacement is the distance traveled in a specific direction or in a specified direction. So displacement might be 20 meters due north, 2 meters north, 60-degree west, something like that. However, if it is just distance will be 20 meters. So there can be a question might come up that you should differentiate distance from displacement, okay? So displacement is a scalar, distance is a scalar rather, and displacement is a vector quantity. So velocity is also a vector quantity because it has a magnitude and direction. and the unit meters per seconds. Acceleration is also a vector quantity because it has both magnitude and direction as well. Unit meters per second square. Force is also a vector quantity. Unit Newton. It is measured in Newton. It is a vector quantity because it has both magnitude and direction as well. So vector diagrams. So usually whenever you're given a question in on vectors, so first thing first is that you want to have a picture of what the question looks like. So this is these are the coordinates, the y coordinates and the x coordinates, right? So when you have something like this, it is divided into 4 points, which are called quadrants. So this is a one quadrant, first quadrant, second quadrant, third, and then fourth quadrant. So the direction that that a particular quantity goes can be in any of these quadrants. Could be here, could be there, could be here, and also could be here as well. So for example, this is a distance traveled, distance of 20 meters in a direction 30 degree to the what? 30 degree of inclination to the what's it called now? To the north. Okay. So this distance 20 meters 30 degree inclined to the north. So let's see. So vector diagrams are shown using an arrow. So yes, the arrow is used to indicate direction. So the length of the arrow represents its magnitude. Yes. So for example, let's say you have two distances. One is 20 meters and the other is 50 meters. So let's say the 20 meter is to be here. This the 20 meter. If you want to draw the 50 meter, let's say it's going to be here. It should be longer. Let's say it should get to this point. It should be longer than the 20 meters. Okay. So you don't expect to draw the same 50 meters to be exactly as same as this way. That will not give you an accurate value of particularly the angle that you want to calculate or something. I hope you get what I'm trying to say.
Yes, sir.
Okay. So vector diagrams are shown using an arrow and the length of the arrow represents its magnitude. So meaning that from here to here, you can just give it a rough estimate. Okay, this should be for 20 meters. And the direction of the arrow shows its direction. Yes, this is the direction of the arrow. Okay. So there's something also important that you need to know. Resultants of two vectors. Okay. So talking about resultants of two vectors, it is a sum or the combined effect of two vector quantities. So when you sum up vector quantities together, the value that you get is the resultant value. And this resultant value is said to have the same effect. It's said to have the same effect as those other forces combined together. Okay. So when you suppose you have vectors in the same direction, suppose you have vectors in the same direction. Let's say they are both pointing in positive x-axis, going this way, going this way. So you can easily add them together because they're in the same direction. So you do 6 plus 4. That will be 10 Newton. Okay. So you can see the arrow head there. So point this way, point that way, they are both in the same direction. So the resultant value will be the addition of these two vectors. So that will be 6 plus 4. And then you have a total of 10 Newton. Okay. So that's one of the ways of getting resultants of two vectors by taking the algebraic sum. Are we still together?
Yes, sir.
Okay. Now, so that is the resultant value that you have there in the red arrow. So that's the resultant value. So yes, also if you have 6 meters, 4 meters, you do notice something. You notice that when you compare the arrow of 6 Newton and 4 Newton, are they of the same size? Definitely no. So you can give if you take 4 Newton to be of this size, then you should expect 6 Newton to be much more longer than the 4 Newton, okay? And then you can see the 10 Newton arrow. You can see that one is even way longer. Can we see that?
Yes, sir.
Very good. Very good. So here you see a length of 4 meters, and then when we're going to put the 6 meters, you see how longer it is. So when you add them together, the resultant value will be 10 meters. So please, who can tell me these 10 meters? What do you think it is? Is it a distance or a displacement? Does it represent distance or displacement?
Displacement.
Displacement.
Thank you. Is displacement. Okay. So 10 meter there is a displacement. It tells you that as you can see there, the two vectors that we added together, they are both um, displacement. So when you sum them together, you have the 10 meters, which is of course longer there. So vectors, how about if you have vectors in opposite direction? So when you have vectors in opposite direction, you're not going to add them together. Okay. So when you have them in opposite directions, you're going to have um, two opposite arrows directions. So let's say suppose you have 6 meters per second and 10 meters per second, and then you can see the arrow directions. This one pointing towards this direction, and then this 4 and 10 meters per second pointing in the negative x axis. Okay, so um, to have the resultant value would simply be what's it called now? You subtract this from this one. Okay, you subtract 6 from 10 rather. So when you subtract 6 from 10, which direction do we think this 4 meters per second will go? Is it going to go in the negative x axis this way or positive x axis? Which one of them?
Negative x-axis.
Okay, thank you. We expect it to point in the negative x axis, okay? So because that tells you that okay, that is the remaining value that needs to be covered by this 6. So this, let's say this from here to here is 10. So if I should cover from here to here to the 6, or rather let me say from here to here is 10, and if I should cover from here to here to the 6, then it implies that the remaining from here to here will be the 4, which is what you have here. Okay. So also let's say you have 6 Newton and 10 Newton, both in opposite directions. You see this going this way and you see this going that way. To have the resultant value, you subtract because they're in opposite directions. So the 4 Newton, of course, where is it going to point to in this case?
Positive x-axis.
Thank you. That will point in the direction of the positive x axis. So you see that go in that direction. Okay, that's very good. So there are some ways of addition of vectors that has to do with angles. Remember that the ones we're dealing with here, they have no angles involved. These are just parallel vectors. These are parallel vectors that are just going on a straight line. On a straight line in a single axis, like in just one axis. Okay. So the axis that we have involved here are just what? The x axis. So suppose you now have a case whereby you have vectors that are involved in multiple axes. This one particularly now is this one is in x axis. However, this one that goes up here is in two axes. Is involved with the y axis and as well with the x axis. So there are some laws that we use in getting the resultants of some of these when you have vectors like this. So there's a way we combine them. So parallelogram law is one of them. So it says that when two vectors are joined tail to tail, they can see tail to tail. This is the tail of this vector, and this is also the tail of this one. So you need to complete the parallelogram. So when you complete the parallelogram, can you see that?
Yes,
Yes.
sir.
Okay, very good. Is Aliyah there already? Where did Aliyah go to?
So yes, sir. But
Where,
sir, I might
where,
not be able to complete this class because
oh,
I'm having exam next tomorrow. Post same exam.
hey, why didn't you tell me?
I forgot to inform you, but I thought you already knew when I told you yesterday.
I didn't know. Oh wow, really? What school is that?
Unilag.
Oh, Unilag. Okay, okay.
Yes, sir.
You want to go to continue your preparation, right?
Yes, sir.
Okay. When I'm done with this session, we'll see what we can do. Okay?
Okay, sir.
Yes. Alright, so for the parallelogram also you have this diagram already. You have this way, and then you have to complete the parallelogram as shown by the animation there. So complete the parallelogram, and then the resultant is found by drawing the diagonal. So you draw a straight line from this tail to tail junction, then to this edge to edge junction. Okay, this arrow up here with short dashes line is assumed to be the same as the one down here. You can see the head to head is the same thing. However, also this arrow on this side as well, that picks up from here to here, is assumed to be same as this one. Okay, so you can see the direction. So at the edge to edge, they meet here, edge to edge collision. They are meeting at this junction. So when you draw a straight line from the tail to the edge to edge junction of those short dashes line, that's line represents your what? Your resultant, as you can see there. And then the arrow goes there to meet every one of them, the both of them together. Are we together?
Yes, Yes, sir. sir.
So now we have uh, a complete parallelogram, and you have in between there you have a straight arrow joining from the tail to tail to the edge to edge point, intersection point, and it is also indicated in red. So this is capital R. Also, we also have the triangle law of vector addition. So when two vectors are joined edge to tail, when they are joined edge to tail, you can see this is one edge and this is another tail. So at this junction is where you have the edge to tail intersection point. So draw the resultant vector by completing the triangle. So you complete the triangle. So you're gonna have a straight line moving from this tail to this edge there. Okay, so you can see that. So you see this and this, they go to join them. And also the direction of this straight line, the one in red, points upward. Don't come and put it to point downward. Why? If for example, you see the direction of this one is going in the x-axis and then it continues up, you don't expect it to continue down. Rather, this one zips it up. It's going to zip it up. So the direction of this one is in opposite to the direction of these other two forces or other two vectors. Okay, so resultant of two vectors. So two vectors, let's say suppose we have two forces applied to a body as shown in the diagram below. So what is the magnitude and direction of the resultant force acting on the body? Who can tell me? Okay, for example, you have 5 Newton pointing downwards. You can see the size, the length of the arrow. I can see the length of the arrow of this 12 Newton way much much longer than the 5 Newton. So when you have something like this, how do we think the resultant would where do we think the resultant will be? So first thing first is that they are joined tail to tail. You can see tail to tail. So this tail to tail, it follows this one, this parallelogram law. Now I need to quickly say something there. Uh, Let me write something on the whiteboard. So when you have uh give me some minutes, let me connect this whiteboard. Okay, I think this we want to load up. I definitely know it will want to load up again. Okay, it's taking so much time to load up. I definitely know it's taking so much time. Let me just use this place quickly. So when you have um based on the triangular law and the parallelogram rather, so we already said that okay, for example, if this is side A, let me say vector A, and this is vector B. So this is parallelogram, right? If of course you have the angle between the two vectors is here as theta. So if that is the angle, the resultant value, which is a straight line drawn from here, let's have the straight line drawn here, or let's complete the what's it called? This point upward. Let's go that way. Oh, sorry. I mean this should be in red. This is red as well. So this as well is going to come here, and this straight line goes there. This is the resultant value. So this resultant value. So calculate resultant value, we simply use this formula r square is equals to vector a square plus vector b square plus 2ab cosine cos of the angle between the two vectors, cos theta. Okay, sorry, I don't know why this is hanging this way. Okay, okay, so plus 2ab cosine. However, for the this that's the parallelogram law of vector addition. Okay, now if you have for the triangle, the one of the triangle, for the one of the triangle, suppose you have this one here, and then you have this one here. So and then you have another one here. So this our whiteboard is really hanging tonight. I don't know what's going on. Okay, I should have the head here. Okay, so from here down here. So this one come down here, continue this way. So you don't expect it to go up, rather you expect it to go down. So I can just, if that place is too rough, I can just come and put it here. But normally it's meant to be a arrow head. Let me just put it at the edge there. I will get what I'm trying to write on the board. Bye.
Yes, sir.
Let me just try to put
Yes, sir.
a arrowhead there. So let me clean the other. Sorry, the board is just hanging, so it's really difficult trying to imagine. Okay, anyways, if this is vector A, I don't understand why it is hanging. You can see how it is how it is displaying there. It's a big problem there. Okay, I think it's responding well now. Sorry. Sorry, this is taking much of our time. So this come here and then this close it up. So this is the arrowhead, which is the resultant value. So suppose this is vector A and this is vector B. So this is the resultant value, okay? So this resultant value, remember I said that the direction of this one points downwards and then continues this way. However, you don't expect it to continue upwards like this. It's not going to continue upward. It's not this one. Because if it continues upward, then this R will not be a resultant value. Rather, it needs to close the triangle. It's going to close the triangle and its own direction will be in opposite to this other two, right? So that you can have that this resultant value R is equal to summation of uh, summation of vector A and as well summation of vector B, okay, and vector B. So this particular triangular law of vector, you can simply use the Pythagoras theorem. So using uh, the Pythagoras. Oh wow. This is taking so much time to load. Okay, so using the Pythagoras theorem, you may also have that r square is equals to a square plus what? B square. Okay, so are we together?
Yes,
Yes,
sir.
sir.
Okay,
Yes, sir.
so suppose you have an angle between them here. Suppose you have angle of inclination. Why is he doing like this? So suppose you have an angle of inclination there. So you may simply use SOHCAHTOA as well. So SOHCAHTOA may also be used in getting whatever values you want to get there. So sine, cos, and tan it. So let's get back to our presentation. I'm even tired of the board set. Okay, so I think we have one question there. It was going. So where were we? I think we were here. Can we see the screen, please?
Yes, sir.
Okay, so let's get back to where we were. So without say two forces are applied to a body as shown, so what is the magnitude and direction of the resultant force acting on the body? So what I'm trying to say here is that you can see they are connected tail to tail at this junction. So when you have them connected tail to tail, remember that you want to use the parallelograms law. You want to use the parallelograms law. However, who can tell me what will be the angle between the two vectors? I think we have this one in presentation first. Who can tell me what will be the angle between the two vectors here? Anybody?
90 degree.
Thank you. The angle will be 90 degrees. Remember I mentioned that you're going to use the parallelogram law. It's the parallelogram law that considers when vectors are connected tail to tail. This is one tail here, and this is the other tail here. And when we describe this, what's it called? When I describe it on the whiteboard here, it is at this junction where they are connected tail to tail is where you have the angle of inclination. So simply implies that that question that we are trying to solve now, this A is not like this, it's not slanted. The A is pointing straight upward. Do you all get it now?
Yes, sir.
So that means that
Yes, sir.
if it is pointing straight upward, that angle theta will definitely be equal to 90 degrees. So that is why that one will now be angle 90 degrees. Okay. So let's quickly go back there. So you complete the parallelogram, which is the rectangle in this case. Well, it's not really necessary that you complete that you make it a rectangular something. So if I were you, since the angle of inclination is just 90 degrees, I would rather just say that okay. So using the formula that I gave here, can we see that? So using this formula here, so for that question now, since for that question, since theta is equals to 90 degrees, so you're going to have r squared is equals to a squared plus b squared plus 2ab cos 90. And cos 90 is what? Anybody? Zero, right?
Zero. Yeah.
So at the end of the day, you're going to have r squared is equals to a squared plus b squared. Now the resultant value that you want to look for, which is r, is equals to, consider your a to be like 5. You give it 5 newton. And the other one is what? 12, right? So that is 12 squared. So that will be 25 plus 144. So we're going to have r squared is equals to 169. At the end of the day, you have r is equal to square root of 169, and that is equal to 30 newton, right? So you don't really what do I say now? You don't really need to do it the way it was done there. So you can just uh, omit drawing a rectangle and what's done there. So yes, when you draw the straight line there, the red arrow. Oh well, it's still the completion of the whole of the parallelogram. Oh yes. So this side is the 5 and this side is the 12. Yes, and then the straight line from here to here. You want to get the resultant value. So magnitude, you see that's 13 Newton. So that 13 Newton, we can also try to get the angle. Maybe in what direction is that resultant pointing to. So remember what we are dealing with is vectors. Can we see here?